In this video, we're going to discuss higher order derivatives. Alright, so we learned how to take the derivative of a function. This creates a brand new function called the derivative, f prime of x. But if it's a function, that means we should be able to take the derivative of it. So what happens if we take the derivative of the derivative? Alright, well, we can keep taking derivatives of functions. We just get another function, we take its derivative, we get that new answer, take its derivative. Alright, these are called higher order derivatives. I guess they're just doing it more often. And they look like this. So if we take the second derivative, that's the derivative of the derivative. The notation is just two tick marks. So our derivative is f prime. This is called f double prime, there's two. Then we have f triple prime. And then the fourth derivative, I mean, you could say the quadruple prime, but having too many tick marks gets kind of confusing to see. So then after the third derivative, we just start putting the number in parentheses right there to represent how many derivatives we've done. So the 100th derivative would just look like that. So really the big ones that we're going to use in practice are f double prime. That's really the most important one other than f prime. Maybe f triple prime. Those are the main ones. And then every once in a while we just see kind of a weird question where you do need to do a 60th derivative or something, but that'll happen more in the spring. And so we want to find the second derivative of this function. And again, nothing's really going to change. I'm just going to do the process that we've been doing twice. So f prime of x, we define the first derivative first, 4x cubed minus 6x plus 16. All right, just doing the power rule. Then f double prime, I think of this as its own new function, and I take its derivative. 4 times 3 is 12 minus 6. Derivative of 16 is 0. All right, so this is our second derivative. Again, if you can find the first derivative, you can find the second derivative because you just do it again. All right, find the third derivative of this function. I'm just going to do this multiple times. If you can do the power rule, you can do your first derivative, treat that as its own function. So now I do the second derivative, I get 6x plus 2. And the third derivative is 6. Right. So when you start off with these polynomials, your derivatives kind of get simpler as you go down. If you start off with more complicated things, sometimes your derivatives get more complicated as you go down. Right now, since we're mainly working with polynomials, our expressions get a little bit simpler because all the constants just slowly go away and we get less and less terms. In this example, we're going to find the 10th derivative, so it's going to take a while. First derivative is going to be 6x minus 2. Second derivative is going to be 6. Third derivative, we know the derivative of just any constant is 0. Oops, that's your third derivative. Fourth derivative, derivative of 0 is 0. Fifth derivative, 0. I think you can see where this is going. 6, 7, 8, 9, 10. By the time we get to the 10th derivative, it's just 0. All right, so for polynomials, if you take enough derivatives, eventually it'll just be 0 forever, because once you get your first 0, every derivative after that is 0, because the derivative of 0 is 0. All right, so like I just said, they're going to get simpler as you go down. Eventually you get to 0, and they just stay 0 forever. So even for this one, if I wanted to figure out what is the 1/1,000,000th derivative, since it already got to 0, I'm going to keep getting 0 forever, even if I do the derivative 1,000,000 times. All right, and here's one for you to try. All right, what is the second derivative of this function? I'll show you the answer in 3, 2, 1. All right, and this is the answer I get, 18x minus 4. That's very important things. All right, you can take the derivative of your derivative, get the second derivative. You can do that again to get the third derivative, fourth derivative, and so on. And since we're mainly working with polynomials right now, if you take the derivative enough times with the polynomial, you're just going to get 0 forever after that.